This is the remove all adjacent duplicates in a string problem, and let me just run it to show that it works. Okay, this is taking a while. Okay, there. As you can see, it works. So just explain this. So I'd suggest you take some time to read it, and I'll just explain the. So pretty much what the problem is saying is that you don't want two letters next to each other that are adjacent in the string. So if you find two characters in a string that are adjacent, you just basically remove both of them. But if you remove both of them, so if you remove two adjacent strings, the string is going to remerge. So as you can see in this example here, you had two B's at first. Let's look at this first example. We had two B's at first. So when we remove the two B's, the two A's are going to merge and they're going to be adjacent next. So you're going to have to remove these two adjacent A's. Then what you're going to be left with is a C and an A. And as you can see, it's what happens in this example. And yeah, you can read this explanation. It explains it very well. So I guess the best approach I could think of to solve this was through using a stack. So any problem that, so the way I look at some problems is the first time I looked at this problem, I just thought, yeah, it has to be a stack, because if you want to remove two duplicates to one another, yeah, it's just such a stack-based problem. And so basically what a stack does is, it's kind of like a list where you can place characters on it. So for example, a stack could have all of these characters, you can place all of them on it. And essentially what a stack does is, when you want to remove from a stack, there's a function called stat.pop which we'll be using, and it basically removes the top element. And the stat.peek, what it does is it peeks at the element at the top of the stack. So let's say you've placed all these characters in the stack. When you do stat.peek, it's going to retrieve the A. And stat.peek, and if you remove the A, stat.peek will equal to the C, etc., etc. And one thing I want to note is that this problem is removing adjacent duplicates next to each other. So two of the same characters can be in the string at the same time. And what I mean by this is, let me give an example. So let's say you put a C at the end. I'm going to run this to show you that it actually works. So the output is CAC, and as you can see, it has two C's left. And that's because the two C's aren't next to each other, so that's allowed. But if they were next to each other, they would have to be removed. So let's get into the algorithm, how I went about this. I'm just gonna type it at the top to show you how it works. So I'm just gonna so essentially what I'm going to do with the stack is, I'm going to loop through the string. So we have this string. What I'm going to do is loop through it. I'm going to place, if the stack is empty, I'm going to place a character in the string, place a character in the stack. So if the stack's empty, place the character in. And then, but there are going to be multiple checks. So if the stack is empty, then place the next character in it. But if there is a character in the stack, what you basically want to do is to check if the character at the top of the stack, equals to the next character. So in this example, we placed an A in the stack because the stack was empty, and the next character is a B. But before we place the B in, what we're going to do is we're going to check what is the character at the top of the stack, and that's stat.peek. So there's this function called stack.peek, and we're going to peek and we're going to check, is the character we're at equals to stat.peek, which is the A. Let me just put this there to show that it's the stack. No. So if that's the case, if they aren't equal, then you place that character in the stack. And then what you're going to do, you're going to loop to the next character, and you're going to carry out the same check. Is the stack empty? No. And is the stack, and okay, if the stack's not empty, go to the else statement. Go to the else statement. Is the stat.peak, that peak equals to the current character? And in this case, the b we're at is equals to the other b. So what we're going to do, if that's the case, we're going to remove the b from the stack. So we're going to pop the stack. And as I said, the stat.pop basically removes the element at the top of the stack. So if the character we're at is equals to stat.peak, just remove the element at the top of the stack. And you can see where we're going with this. And the next character we're going to loop to is A. And A, as you can see, the stack's not empty. And yeah, that's essentially how it works. And as you can see, the stack is not empty. Is stat.p equals to the current character? Yes. So what you're going to do is you're going to pop the stack, and you're not going to add that A to the stack. And then, is the stack empty? Yes. So push a character. Is the stack empty? No. But is the stat.peak equals to the current character? No. So you push that character on. And that's essentially how the algorithm works, and it works out perfectly fine. And as you can see, I wrote the entire algorithm right here. So this is a for loop. Is the stack empty? I do this check. So if the stat.peak equals to the character at the current character, then you pop the stack. Else, you push the character onto the stack. So if the stack's not empty and the two characters aren't equals, then you push the other character to the stack. But if the stack is empty, then you just push the character onto the stack. So in this case, so a stack. So what we basically did is we created a character stack, and we need to return the output as a string. So a stack is not a string. So what we would need to do is convert the characters in the stack to a string. So I created a string builder. And essentially what a string builder is, I don't fully know how to explain it properly, but essentially what it does is a string builder is kind of like, just think of it kind of like an array, which stores a bunch of characters, letters, a bunch of characters. And what you're going to do is, while the stack is not empty, what you basically want to do is pop the stack. And what a stack does is it removes every element from the stack. So in the case of the stack, we have the C, and in this example here, we have a C and an A. So while the stack is not empty, you pop the stack. So while the stack's not empty, you pop A, and then you pop the top element A, and then you append that A to the string builder, and then you append the C. But as I said, a string builder is not necessarily a string. It's kind of like some sort of array or something. And so what you would need to do is convert it to a string. But as I said, when you pop a stack, it pops out the last element. So in this case, the first element that's going to be popped is an A and then a C. So currently, in the string builder, this is how it's returned, and it's an A that comes first and it's a C that returns second. But as you can see in the output, it's meant to be a C and then an A. So what we would need to do is basically reverse the order, and that's what I did. So I did the string. So I basically reversed the string builder array, and then I converted it to a string, and then that would give the correct output. And that's how you basically solve the problem. So I hope that was helpful. And let me just